Hi everyone, I'm Shada and welcome back to the channel. In this video, we're going to create a proper rectangular sketch in CATIA using Python and PyCATIA. This might sound simple, but if you've ever tried a sketch automation, you know constraints can easily break your geometry if they're not applied correctly. And actually, in this example, we'll go through real errors we encountered, understand why they happened, and then fix them step by step, just like in real automation projects. Also, as always, I'll upload the full script to my GitHub, and you can download it and practice yourself. You'll find the GitHub link in my channel profile, and let's get started. Step 1. Connecting to CATIA and creating a part. First, we connect Python to a running CATIA session. Then, we create a new cat part document and access the part object. This is the base of almost every PyCATIA automation script. Next, we get the part body, and this is very important. In CATIA, sketches belong to bodies, not directly to the part. This is a common mistake and one reason why people get attribute errors. Step 2, creating a sketch on the XY plane. Now we access the origin element and get the XY plane. We create a sketch inside the part body on that plane. Once the sketch is created, we open it for edition using Open Edition. This gives us access to the 2D geometry factory. From this point on, we're working exactly like the CATIA sketcher, but through Python. Step 3. Drawing the rectangle geometry. Here, we draw 4 lines. Visually look like a rectangle. At this stage, the rectangle looks correct, but geometry alone is not enough in CATIA. Without constraints, CATIA considers this sketch under constraints, and it's free to move or collapse later. Common mistake. Now, this is the most important lesson of this video. Initially, it's very tempting to apply coincidence constraints directly between lines. But in CATIA, when you apply coincidence between 2 lines, CATIA may decide to place them on top of each other. All the lines will be collapsed and overlap. So if your sketch suddenly turns into a mess, this is usually the reason. Step 4, the correct way, point-based constraints. The correct approach is to work with endpoints of the lines. We extract the start and end points of each line. Then we apply coincidence constraints between a point and the next line. This tells CATIA exactly which endpoints must meet without giving it freedom to collapse the geometry. This is same logic CATIA uses internally when you sketch manually. Step 5, adding dimensional constraints. Once the geometry is connected correctly, we add constraints. We apply a length constraint to the bottom line and a height constraint to the vertical line. Now, the sketch is closed, stable, and dimension driven. Step 6. Closing the sketch and updating the part. Finally, we close the sketch edition and update the part. CATIA now fully resolves the sketch and we get a proper constraint rectangle ready for paths, pockets, or parametric design. So in the end, we have a valid CATIA sketch, correct constraints, no geometry collapse, and behavior that's fully predictable. This structure is exactly what you should use in real automation projects. I've uploaded the full script to my GitHub repository, so you can download it, test it, and experiment with your own dimensions. Don't forget to like, subscribe. Thanks for watching, and as always, happy automation.